In today's video, we're going to take a look at the equation V equals IR and at some important current versus potential difference graphs. V equals IR is probably the most important equation in the electricity topic and stands for potential difference or voltage equals current times resistance. So if we had a circuit with a current of 4 amps and a resistance of 2 ohms, then the voltage of our cell must be 4 times 2, so 8 volts. Or for another example, if we had a 24-volt battery which was producing a current of 8 amps, then to find the resistance we'd have to rearrange our equation to R equals V over I, and then do 24 divided by 8 to give 3 ohms. Now this equation also tells us about the relationship between voltage, current, and resistance. As long as the resistance stays constant, then as we increase the voltage, the current should increase proportionally or vice versa. And we can see this if we plot a graph of current against potential difference. As the potential difference increases, for example we use a bigger battery, the current produced in the circuit would also increase. And this negative part down here just shows the same thing, except the battery is attached the opposite way around, so the voltage and current are effectively negative. We get these nice straight lines in circuits that contain only wires or resistors because for these circuits, the resistance stays constant the entire time, which remember was the requirement we mentioned earlier. If we used a different wire or a different resistor, the line would still be straight but it would be more or less steep. For example, a bigger resistor would have a less steep line like this one for a 10 ohm resistor, while a smaller resistor would have a steeper line. You can think of this in terms of how much potential difference is required to produce a given current. If the circuit contains a smaller resistor and so less overall resistance, then we only need a small potential difference to drive a large current. One thing to mention here is that we're assuming that the temperature stays constant. If we increase the temperature, then the resistance would also increase, and in reality higher currents do generally cause wires to heat up if they are left on for a while, so in practice the lines don't always look quite this straight. The next thing we need to look at are the graphs of filament lamps and diodes. Filament lamps are just light bulbs which contain a very thin metal filament, and as the current flows through the filament, the wire heats up until it's so hot that it emits light. All of this heat massively increases the resistance though, and so the curve gets less steep as we increase the current, which is just showing that less current can flow per unit of potential difference at these higher voltages because the temperature and resistance is so much higher. Diodes on the other hand are devices that only allow current to flow in one direction, which is why they only show a current when the potential difference is positive. They do this by having a really high resistance in the reverse direction so that effectively no current is going to flow in that direction. Anyway, that's all for today, so hope you enjoy the video and we'll see you next time.